By now, you have a lot of knowledge about this data set. This data set is made up of some shops, because remember, a student is trying to analyze the determinants of demand in the alcoholic beverage industry. Okay. And the factors that can affect the demand. This was a thesis of a student. The person is looking at the impact of location, the impact of occupation, as well as the impact of religion. And so the person collected this data for Brukutu. Brukutu is a company. The Q is a quantity demanded of gin bitters. It is the dependent variable. That is the dependent variable. Okay. And this quantity demanded of gin bitters is supposed to be affected by the price of the gin bitters, the complement price of the gin bitters. It is also influenced by the income of the people. Okay. So if the people's income go up and the good is a normal good, then they will demand more. But if it's an inferior good, they will demand less. It is also influenced by the quantity demanded is a dependent variable, the price and the complement price and the income of the people. Those are all independent variables. Then the location, occupation, and religion are also independent variables. So the first question I want you to tell me, oh, by the way, everybody lower your hands now. Please lower your hands. And then tell me which of these variables are categorical variables and which are numerical variables. Which of these are categorical and which are numerical? Okay. So by now you should have some ideas. Rebecca.
The categorical ones are the ones which have the figures. That is the Q, the numerical Q, P, C, M. And the categorical one is the one with the letters, the location, occupation, and the last one with the Muslim, REL.
Religion.
Religion, okay. Thank you.
So these are the variables. And how many dependent variables do we have? How many dependent variables do we have? Rebecca. Oh, Dorothy, how many?
Hello, say.
Answer, just answer.
One. With the location.
All right, so she said it. She said, Rebecca, Dorothy has made it simple. I think you should check it the way you raise your hand. I think sometimes it delays. All right, so the dependent variable is only one, okay, and that is a Q. Now, what we want to do is, I want you to take the data set into R. So you have this command already in R. I'm going to go to my R and show you. So you to go to your R, you have the data set in R. So I want you to load the data in R. So I'm showing you my R screen here. So you to try and show. So this is the data set. Let's go to the data set again. So this is the data set. And last time we've looked at correlation already. So the data set is gin. So I want you to go to your Brukutu for R. Go to your Brukutu for R and then copy that data set, the one I showed you some few minutes ago. Copy that data set, and then come to this your command called gen equal to read.delim. Come to that command and then run it. Okay, come to that command, click on that command, and then at the top, click run, or do Control Enter to run it. The data will be loaded, and you'll see the command written blue in the console, which shows that the data is loaded. In order to see that the data is truly loaded, just highlight only the gen. Look on my screen, you see that. Highlight only the gen, and then run that. When you do that, the entire data is supposed to show. If it does not show, like mine did not show, then you have to reload it. So you have to copy and then come and reload it. So do that. However, if yours is showing, just like mine is showing now, if yours is showing, please raise your hand and let me be sure. The data must be showing down there in the console, just like mine is showing down there in the console. Raise your hand if your data is showing. Only Freeman's hand is up. Raise your hand if your data is showing. We got 4 people. If you have a challenge, it's important that you ask a question right now, because once we go further, it's going to be quite difficult to return to this. So if you have a challenge right now, you ask your question right now. Once you are done, raise your hand. Okay, once you have the data showing down there in the console, raise your hand for me to be sure the people I'm starting with. Okay, we've got a Ecosia force in joining the creme de la cremes. KP Lom, use your full name. I'm about to give you mine, so it's important you all use your full name. Those of you who are not using your full name, please use your full name or your ID, but use your full name. Use your full name. Okay, so we've got 9 people who have raised their hand. Now we have a 10th person. The person with the name KP Lom. I will not count you if you do not use your full name. It looks like you are yet to be with us. Okay, so we've got those 12 people. And these 12 people you're supposed to go along with me. Okay. I'm taking a picture of the screen. All right, so you are the ones who have your data showing. What it means is that the rest are probably using their mobile phone, and so they are not really working on their laptop with us. Somebody probably is even sitting in a car, and so the person.
Dr. Mine has now come.
You don't have to tell me, you just have to raise your hand. You just have to raise your hand and I will know. All right. So now that you are showing the data, I'll ask you this very thing in an exam. What you just did, I'll ask you in an exam. So it's important that you are with me. Okay. Now let's go to the next thing. The next thing is to print into the memory of R. Print into the memory of R this data set. Okay. And we do that by using the command attach. So you see the command known as attach. Run that command. There is another command called detach. Don't run it yet. You normally do the detach when you have finished everything. So run your attach. Whatever shows, don't worry. Whatever shows, don't worry. Let me see something. Okay. So run your touch. And then once you're done with that, we are going to do our first plot. And here is a question. This question will be asked in both your assignment and in your exam. I can ask you to determine whether any of the numerical variable is normally distributed. Write it down, okay, because most of these things you might forget. I can ask you whether quantity demanded is normally distributed, whether price is normally distributed, whether complement price is normally distributed, whether income is normally distributed. But I cannot ask you whether location, occupation, or religion are normally distributed because they are not numerical variables. So take note, it is for the numerical variables. Now, I think that in your command, I asked you whether price is normally distributed. We checked that last week. Okay, so go and look at the rest by yourself, whether any of them is normally distributed. For now, we are going to look at simple regression. A simple regression. Just remember yourself about the few things we learned about correlation. We are doing a further level of correlation, and that is regression, and we are applying it in R. What is the difference between the simple regression and the multiple regression? Who can tell us? Please lower your hands, everybody. What is the difference between the simple regression and the multiple regression? What is the main difference? Yes, Nyako.
Okay, Doc, the simple regression has one variable and then one dependent variable. But with the multiple, the simple regression.
What you said was not clear. Okay, let somebody take over.
Okay, sorry.
Agitate on it. Okay. Take your time. Take your time. Okay. Maybe you just raise your hand. You didn't really think it through, but think it through. Yes, Dorothy.
Doc, the simple regression has one dependent and then one independent variable. And then the multiple regression, there's one dependent and multiple independent variables, the number of independent.
Okay, so that is the difference. What we are about to do is that we are going to run the simple regression first. Okay. So what I want you to do is to run this command, which is the plot of the simple regression. Okay, we are going to plot it. So do the plot kill this with the tilde sign, okay, P. So quantity demanded is regressed on the price. Do that. And when you do that, you will have the scatter plot as well as the red fitted line. Some of you will not get the red fitted line. If you don't get a red fitted line, let me know. Almost all of you will not get that. But if you don't, let me know so that I'll show you how to go around. Efia, you didn't get, right?
Yes, please, I didn't get.
So what you would now do, for those of you who didn't get, you are going to run the gene sample. It's another command before you run the plot. Run the gene sample, it will give you some results, like mine is showing down here. It will give you some results. Then you go back and run the plot. Now it should work. Did it work, Efia?
Yes, please, it did.
Good. So now this is a simple regression. It's a simple regression. It's just showing the relationship between quantity demanded, which is here, quantity demanded, and price, okay, which is on the axis here. My question I want to ask you is, tell me though, what do you think is the relationship between the quantity demanded and price? Just looking at a graph. What is the relationship? If you are here, talk, because everything is under record. Okay, what is the relationship? Safako.
Please, it has a negative relationship.
Okay. What shows is a negative relationship?
Okay, the higher the price, the lower the quantity demanded.
Awesome. Excellent. Now let's go to the table. This time the regression table, not the graph. You will notice that there are some important things there. It shows only one independent variable, which is the price, and you see that one here. And the last time we indicated that there are other factors that can affect the quantity demanded. Okay, because there are other things when you are writing the equation. So if we are writing it, it becomes Q equal to, this is what I'm doing is called the specified regression model. Beta naught, okay, plus beta 1 price plus the error term. Do you remember we spoke about this specified model versus the estimated equation? You guys remember? Did I talk about it? Using the wage example.
Yes, yes.
Good.
Yes, please. Yes.
So now, given what I have done, we need to find out the numbers, because we did mention that the beta parameters are numbers that you have to replace. Okay. And then we expect that the error term will go to what value? Who can remind us? This error term, we expect that it to be what value? Actually, when you watch the videos or you look at assumptions of the regression, you see Kofi Baden.
We expect it to be 0.
Perfect. So the mean of the error term is expected to be 0. Take note. And in one of your assignments, I've asked you to prove that with your own data. So take note. So looking at this simple regression, the main determinant of demand or quantity demanded is the price. This price is the main determinant. And what we have here is the regression model. So this is a model. It is not the regression equation, the estimated equation. If we want to write the estimated equation, who can tell me how to write it? Remember, the U would have simmered into 0. Okay. How would a simple regression be like? I mean, you got to be extremely good to tell me how to do this. Isaac, let's see whether you can try. Oh, Isaac, your hand was not up.
I'm up. So
Okay,
it will
good.
be Q is equal to 390.376.
Okay, use 2
plus,
decimals.
Okay, so it will be Q is equal to 390.38 plus minus 14.26 P.
Very good. Excellent. Very good. Very good. That's wonderful. So this is it. So what we have down is the regression model, the specified regression model. And what we have up is the estimated regression equation. So that shows that there's a negative relationship between price and quantity demanded, and that when price goes up, the quantity demanded will fall because of the negative sign. It will fall by 14.26. We'll come to proper interpretation later. Okay. Now, what is indicated by the stars? We'll come to that. When we get to multiple regression, we'll learn a lot. What is indicated by the R square? We'll talk about that when we get there. What is indicated by the adjusted R square? Okay. And what is indicated by the p-value of the F statistic? Because this is a simple regression, I'm not going to be talking a lot about it, but I want you to check the multiple R square, which is also called the R square. What is a value? In percentage, what is the value of the R square? In percentage, what is the value of the R square in this simple regression? Solomon.
75%.
75%. Keep that in your mind. So using only the price, the R square is 75%. What about we use not only price, but all the other independent variables? What will happen? Okay. We'll see that. Okay, so for now, that is it. Now, before we proceed, I told you that you can check whether the mean of the error term is 0. So there's a command there. Before you can check whether the mean of the error term is 0, you need to check something. Now, the error term is actually the difference between the actual value of Q and then the predicted value of Q. Okay. And again, when you check the slides, you know. So the error term is equal to the actual Q, the actual dependent variable, the one you will find, the one you got from the data, minus the predicted Q. Which one is a predicted Q? The predicted Q is something we are going to, is the actual Q that fit the line. So let's call it, we call it Q cap. Normally that's how we call it, Q cap. Okay. So it's a Q minus a Q cap. That is the error. And the Q cap is the predicted Q. It is also called the fitted. The fitted. Now, I want someone to tell me the actual value of Q for the first observation. Looking at your Excel data, you'll know this. The actual value of Q for your first observation. Who can tell me? The actual value of Q. If you look at the Excel, the first observation, what is the actual value of Q? Yes, Abraham.
160.
160, that is correct. Okay, so you have 160. Now, we are going to find the predicted value for all of them, and then you check that of the first observation as well. So how do you do that? If you want to find that, all you have to do is to run the command known as fitted gen sample in our case. Fitted gen sample, this command. Run it. And when you run it, you will see the predicted or the fitted value for the first observation. What is the value? Who can tell me? Who can tell me that value? Here is on our screen. What is that value for the first observation? They are all down here. Florence.
162.
Florence, use your full name.
Sorry, 162.16.
Okay, so the actual was 160, but then the predicted is 162. So that means that there is a difference of about how many?
-2.
-2. So to that -2 is what value? That -2 is what value? Abbas.
The fitted value.
The error term.
The error term. Okay, Abraham, see, that's why you don't have to answer questions when you're not called, because you always get it wrong. So wait to be called before you throw dust into our eyes. So it is the residual, is the error term, because I've just written it here, up here. So let's go and run the residual. There's a command you can actually use to run the residual to confirm the value Abbas spoke about. So run your command in your work called residuals gen simple. Let's run that and see. And now that we've run that, you will notice that the first information, you'll notice that the value we have for the first observation is exactly negative 2.16. So that is the error. Now, I think Isaac mentioned that some of the errors will be positive. So you can see that some are negative, some are positive. This one, for example, is positive. This second one, next one is negative. Okay. So some are positive, some are negative. And we said that the mean of all of them will be equal to what? The mean of all of them, Isaac.
It should go to 0.
0. So let's run that and see. There's a command called mean of the residuals. That's the next command, mean of residuals. Okay. So let's run that. And you see the results down here in the console. Now, what is that exact value? Who can interpret the value that you get down here? What does that value mean? What does that value mean? Yeah, Solomon.
It means it's negligible.
Yeah, so what is that value? It's approximately what value?
Negative infinity.
Oh, Maza. No. Dorothy.
Doc, it means that there are about 16 zeros before the 4.4409. So it's 0.000. So it's almost like 0.
Exactly. It's not infinity. And the negative doesn't matter. This number is closer to 0. Remember, 0 is closer to negative and is closer to positive. Whether it is positive or negative, you just have to use the absolute value to explain. And this means that this number is approximately 0. There are 16 zeros before the 4. So it's just 0. Even if there are 5 zeros before the 4, it is 0. So this truly confirms that the mean of the error term is 0. Okay. The other things you can check, and I want you to do it on your own. Rounding the gen sample to get a confidence interval. And then generating the ANOVA for the data. You can run all of them yourself. Now, you can also plot a 3D graph. You see, what we've just done here is a 2D graph between quantity demanded and price. But I want to add complement price to it so that we get a 3D graph. To do that, you should run a command known as library RGL. You got to install the RGL and then run that command. And then library car. Let's do that. Now that you've done with that, you go and then run the command known as scatter plot or scatter 3D. Scatter 3D. Okay. When you run that command, and again, you should be doing this along with me because sometimes I'll be asking you whether you've done it. So I just run mine. When you run it, you will not see the results. The result will pop out rather in a different window. Mine has popped out in a different window. I wanted to show you, but if I try to show, this one will go off. And that means that I can also not write on the screen. Let me see. If I go back, I might not be able to write on the screen. Let me see my hands. Those of you who have gotten their 3D scatter. Let me just show it, whatever happens. So you see my 3D scatter plot. You see it moves. As you click and drag it, you see that it moves. Okay. As you click and drag it. The point, if I do it like this, it becomes a line. Okay. If I do it like this, it becomes the relationship between price and quantity demanded, just as we had before. Okay. That's how it looks like. And the gap above is green. The gap below is red because they are the errors. The errors above are positive, the errors below are negative. Okay. And because we have gotten complement price, this time is no longer going to be a line as you see. Now you can drag it and it becomes a surface. Okay. So this becomes a surface, indicating that we are dealing with a 3D. If you get a 4, then it becomes, polyhedral and things like that. And so, but this is just to let you know that as you move from 2D graph to 3D and multiple Ds, then the thing becomes complex. That is why we don't use graph to show them again. All right, let me go back to my I hope you saw the picture. Well, I hope you did. You can also plot another one. It's that one you got to install a scatter plot 3D. And when you do the scatter plot 3D, you can run this command, which is with data equals to Jane. Then the scatter plot. Your X is your Q, your Y is your P, and your Z is your C. So this one doesn't give you a true 3D or a true moving 3D, but it gives you a picture, a true picture of the 3D. So as you can see here, you are able to see the movement, not a movement, but a cuboid of the C, Q, and P. And you see the plot inside it as well. All right, so we are done with graph. We are now going to go to the real reason why we are here today, and that is doing the multiple regression. In real life, we don't do simple regression, we do multiple regression. And in your assignment and in your exams, you'll be doing this multiple regression. So ask questions, very important you do, because this will be a compulsory question. So let's run the command known as gene multi. Gene multi. There's a command you have called gene multi. Okay, and that gene multi has all the data. So we are now doing multiple regression, specifically dummy variable regression. So we are doing multiple regression, dummy variable regression. So run that gene multi, and you will get this beautiful result that you see here on your screen. It's a beautiful result. I don't know whether you see it as beautiful, but for me, it's beautiful. Okay. All right. So let me show you the situation again.
Thank you.
Thank you. So to determine the statistical significance of any independent variable, and like I've said, the intercept is not an independent variable. It has no economic interpretation. It's only for beautification and cosmetic purposes, except during prediction. That is when it becomes useful. The estimate divided by the standard error will give you the t statistic, which when you read from the table, it will give you the p-value. The p-value is what we call PR, or the probability. The independent variables, each one of them have got an estimate, and these estimates are also called coefficients. Each coefficient has got a standard error. Each standard error has a t-statistic. Each t-statistic has got a p-value. Each p-value has got an empty star or some stars. The question is, how do you tell whether an independent variable like price is significant? Now, when you say it's significant, this is what we mean. What we mean is that price is important in predicting the quantity demanded. That's what we mean by significant. It is significant in the sense that it is not just there. It is not just there to influence, but the influence is significant. You see, there are some people in a company, they are there. But there are some people, they are there to influence the move of the company. Okay, so their presence is statistically significant. To determine which of these variables is statistically significant, you use their p-values. It is their p-value that will guide you into determine whether the variable is significant or insignificant. Is their p-value. How do you use the p-value? Well, whenever the p-value of that independent variable is less than or equal to 5%, then that independent variable is statistically significant. And that's a key point you want to note. When the p-value of an independent variable is less than or equal to 5%, then the coefficient of that independent variable is statistically significant. So, before you determine the statistical significance, it's always good to convert the p-values to 2 decimal places, 2 dp. And this is just my rule for you. Convert the p-value to 2 decimal places. Then now you check it against 5% alpha. Once you do that, then we can now conclude that you are dealing with true significance. So let's go to, remember, because the intercept is not meaningful, we will not do anything with that. We'll rather go with P, starting with P. So using the P value for P, who can tell me, is P significant or insignificant? Mackensen.
Significant.
Why?
Because at 2 decimal place, the p-value is less than 5%. Oh, yes.
You always have to mention for me what it is before you tell me that it's less than 5%.
Yes.
Tell me the exact value of the p-value.
The value there at 2 decimal place is 0.05. And that's equal to the 5%.
Good. That's it. That's it. If we had used the next decimal, if it was not 2 decimal, but it was 3 decimal, then the value will be 5.3. Okay, if you check it, you see that this value will be 5.3, which would now mean that price will not be significant at 5%. I'll come and talk about the stars. Yes, Gilbert.
Thank you. Please, I want a little clarification on this. You mentioned that you move to 2 decimal places. By 2 decimal places, do you mean, so we have 0.05, you move 1, 2,
yes.
So you are going to get 5.3. You get 5.3.
No, you go 1, 2, okay, from the dot, you move 1, 2. So you stop at 5. And anything after where you stopped is not part of it.
Okay, so in that case, what will be the value? Would the value then, after moving to 2 decimal places, be?
The value you see there is 0.05311. Okay. So when you are moving, you move 1, 2. That is 2 decimal. So what you now get is 0.05. That's where you end up. So it means that the p-value for price is this, and this happens to be equal to the 5%. We said that yes, for you to be significant, you must be equal to 5% or less than 5%. And it's equal to 5%, so it's significant.
Okay. And then you mentioned that assuming it was 3 decimal places.
Yes, assuming it was 3 decimal places, you now move another step. So it becomes 0.053. And this value here is not 5%. It is 5.3%.
Which is greater than?
Which is greater than 5%.
Okay. But before then, you had mentioned that we should stick by 2 decimal places.
Yes.
Is that what we should commit ourselves to? So
yes,
we don't.
That is what I am restricting you to for this.
Okay, thank you.
Good. So ladies and gentlemen, if you ask questions like this, you get answers. You sit down and you don't ask questions, you don't get answers. That's how it is. And sometimes you may want to justify yourself, oh, but I got to understand before I ask questions. Well, it starts from somewhere. You got to ask questions because you don't understand. Anyway, so let's go to complement price, which is C. Complement price. Who can tell us complement price? Is that significant or is not significant at 5%? Remember, we are looking at 5%. Complement price. And by the way, complement price, by that we are looking at the C, which is this. Okay. So who can tell us, is that significant or insignificant? Okay.
Hello, sir. It's insignificant.
Why?
Because at 2 decimal places, it is 0.00, which is less than 5%. So it is insignificant.
All right. So if you had the mark, that was very wrong. First of all, your 2 decimal place answer you gave was wrong. And second, your conclusion is also not correct. So let's give it to another person who will come out clean on the other side. Joanna.
Yes, sir. It's significant because the p-value is 0.01 at 2 decimal places, and it is less than 0.05. So it's significant.
That's perfect answer. So the p-value, when you check it carefully, and again, you guys want to follow the approach I gave. That's why Gilbert asked further questions. If you convert this to 2 decimal places, that is 0.01. Because when you convert it and you get 0, it would have been 0.00, but the next value is 8. And 8 is bigger than 5, so you bring 1 on top to the next one. I mean, you know how to do decimalisms. This is on the high school. Then you check whether that value is less than 5%. And if it is less than 5%, then it's significant. Okay, now let's go faster to the other ones. We are delaying here. M, is it significant or is not significant? M. M, please mute yourself. I'll call you. You shouting the answer doesn't make you the smartest. Isaac.
Dog, it is insignificant because at 2 decimal places, it becomes 0.20, which is greater than.
So how many percent is that? 20%.
That's 20%, which is greater than 5%, making it insignificant.
Good. That's fine. That's perfect. Now let's go to Loch Urban. Loch Urban. Is that significant or insignificant? Loch Urban. And that is the next one. Abbas.
Dog is insignificant.
Very good. It's insignificant. How many percent is that?
19%.
90%. Perfect. Teaching. Who can tell us? Is that significant or insignificant? Teaching. Dorothy.
Doc is significant.
Very good. Forget. We know what you're saying. Trading. Is that significant or insignificant? Trading. At this stage, we are flying. Hansen.
Significant.
Real Christians. Is that significant or insignificant? Real Christians. Emanuela.
It's insignificant.
Hey. The previous guy, what did he say about the trading? The one who spoke on trading, what did he say?
So I said significant.
Okay. So real Christian, Emanuela, that was wrong.
It's significant. It's significant.
Because you have said, because then you are doing lottery. Okay. Richard, is that significant and why? Richard.
Yeah, it's significant.
What is a p-value?
Hello. Yes.
The value is 1 point.
No. I don't want the answer. I want a simple answer. If you know the p-value, you know the simple answer to it. Let's go to Isaac. What is a p-value?
It will be 0.00.
Isaac, I don't want that answer. Forsen, what is a p-value? Forsen.
It will be 0.
Okay, it's 0.
Yeah.
It's 0. Let's move on. It's 0. Okay, at this stage, you guys have to know these things. Real Muslims, is that significant or insignificant? Real Muslims, is that significant or insignificant? Dorothy. Real Muslims. Abbas.
Dog is significant.
P-value is what?
0.
Perfect. Okay. So guys, go and learn this. Go and learn this because you got to grow into this. Okay. All right, let's go to the next slate of questions. Okay. Let's go to the next level of question. And these are, by the way, examinable, highly examinable in your assignment as well as in your exams as well. All right. The next set of questions go like this. So first, you've been able to tell individually which of these variables are significant. What about if we put all of them together? That's the next question. So the next question is, are the estimates, that is a coefficient, are the estimates jointly significant? Jointly, the key word is jointly. Are the estimates, are the coefficients jointly significant? Now, I'm highlighting something because anytime you hear of joint significance, this is what you use. So you should note down that to determine joint significance, joint means put together. The previous one was partial significance, individually. This one is jointly put together. All the coefficients put together, all the independent variables put together, are they important combined together? You always use the F statistic, the p-value of the F statistic to judge joint significance. You always use the p-value of the F statistic to judge joint significance. And the p-value of the F statistic here, okay, is always supposed to be 5% or less, just like the previous one. So when the p-value of the F statistic is 5% or less, then we can say that the coefficients are jointly significant. When the p-value of the F statistic is 5% or less, then the coefficients are jointly significant. So who can tell me in our case, would you say that the coefficients of the independent variables are the coefficients jointly significant in this Brukutu gene beta story? What will you say? Will you say that the coefficients are jointly significant or they are not jointly significant? Yes, Dorothy.
So I would say they are jointly significant because the p-value we are seeing is 2.2 e minus 16, which is like 0.00016 times, and then the 2.2, which is almost like 0. So it's less than the 5%, so it's jointly significant.
Exactly. So this p-value is 0. And guys, by now you should be learning how to read this E minus E plus E minus E plus. By now, you got to know how to read it all, because that reading is what will guide you. So we know that from this, the p-value is approximately 0. And since this p-value, which is approximately 0, is less than the alpha level, which is 5%, then we can say that the independent variables are jointly significant. That's it. If you have a question on that. So it's just a p-value we are using here. It's a p-value. That's what we are using to make our judgment. Judith, do you have a question? Isaac, do you have a question?
Yes.
Okay, Judith, go.
Okay, please, I wanted to find out what's the interpretation of them being jointly significant with respect to the various variables we have. So how will you say it?
Okay, how would you say it, or you want to really understand, or you want to know how to say?
Oh, so the first one, when we interpreted it, we said that the price would affect the quantity. So now that everything is significant.
So what this means is that when you combine all the independent variables together, even though some of them individually do not influence the quantity demanded of generators. Which ones? Those that don't have stars. Go and check those that don't have stars. For example, income. When we're mentioning income, we said that it is insignificant. When we're mentioning urban, location urban, we said it was insignificant. So some of them were insignificant, but all those that have stars are usually significant. Now, and how many significant are they? For your information, when the stars are 3, it means that it is significant at 0.1%. Take note. When the stars are 2, it means that it's significant at 1%. So 1% is when the stars are 2. 0.1% is when the stars are 3. And then 5% is when the stars are just 1. And then when it is significant at 10%, then we say the star is a dot. So when the star is a dot, then it means that thing is significant at 10%. So when you look at P, for example, there was a dot there. So even though P was not significant, especially when you're taking all the decimals, P was not significant at 5%, but it was significant at 10% because it's a dot. Now, when you get to the F statistic, the P-value is telling you individually, some of them may not be significant, but jointly put together. You've heard of our folklore that says that, you know, a bunch of a broom together is stronger than a stick, a broomstick, because there is unity in strength. And that unity in strength is measured by the p-value of the F statistic. So it is telling you how combined, put together, whether they are all influencing the quantity demanded in this case. Does that answer your question, Judith?
Yes, please.
All right, Isaac, before we go to Joanna.
Doc, first and foremost, I want you to repeat the stars, the meaning of the stars. And then my main question, I wanted to find out, does the F statistics value, does it have any interpretation on the regression that we just did?
No, it has an interpretation on regression in terms of significance, not in terms of the fitness of the regression. And we'll come back to that one. So yes, it has interpretation on the significance, the combined significance of the variables. That's the only way you interpret it. Remember, it's a hypothetical, it's a test statistic, just like p-value, just like z-value, just like the W, okay, which is the Shapiro-Wilk test, or the Kruskal-Wallis test, or if you can remember the U, which is a Mann-Whitney U test. The F statistic is also like that. Okay? And all it's doing is that it's telling you the combined influence of all the variables on the dependent variable.
Well, so can you repeat the stars? Yes.
I said that when your stars are 3, it means that that variable is significant at 0.1%. So if you look at all these last 4, which have 3 stars, what it means is that they are significant at 0.1%. And note that once you are significant at 0.1%, you are automatically significant at 1% or 5% or 10%. That's what it means. It means you are strong, you're strong, you're strong. You are very close to 0. That's what it means. And I said that when the stars are 2, then that particular variable is significant, not at 1%, but sorry, not at 0.1%, but at 1%. So if you look at a variable like complement price, okay, complement price has 2 stars. So that 2 stars shows that complement price is significant at 1%, not 0.1%, but 1%. And then when the star is 1, it means that that variable is significant at 5%. And when it is a dot, it means the independent variable is significant at 10%. How is it calculated?
Thank you very much.
Now, let's go to the next set of questions. So we've done 2 questions. One is about individual variable significance. And then one is about the joint significance. That is all of them put together. Let's go to the next question. The next question is a little bit tricky, and it is this. Is the regression model well fit? Is the regression model well fit? Is the regression model well fit? Now, what does that mean? And I think, Isaac, you asked a question some minutes ago, and it kind of answers this in part. You said that, how do we know the interpretation of all the variables in terms of how they are affecting the dependent variable? You see, one of the things you should know about this regression and any other regression is that there is an independent variable, in this case, Q. And this Q is a function of, meaning it depends on price. It depends on complement price. It depends on income. It depends on location. It depends on occupation. It depends on religion, okay? And so several other factors. Price dependent, but the question is that in percentage terms, if you can remember the F-test was guiding you that combined, are they significant in affecting the quantity demanded? Combined, put together. So if I go and take these guys and then put all of them together, are they jointly affecting the dependent variable? The p-value of the F statistic guided us. But it didn't tell us a percentage impact all of them are given. In terms of percentage, how much are all of them affecting the dependent variable? In terms of percentage alone, nothing else. The thing that would tell us is known as the R square. The R square. The R square is what you use to determine the fitness of the regression model. And I'm going to talk about it in several ways. The R square is it's also called the coefficient of determination. The coefficient of determination. I'm about to explain it well for you. But the R square is what you use to determine the reliability of the regression model. Another word for the fitness of the regression model is the suitability or the reliability of the regression model. It measures the power of the regression model. Guys, you see the words I'm using. The suitability, the reliability, the power of the regression model. A higher value generally indicates that the regression model has a better fit. A lower value of the R square tells you that the regression model has a lower fit. It's not a good fit. And it is in percentage. So what really is this coefficient of determination? What is this R square? Well, the R square measures, and this is important because this is a definition. It is a fraction or a proportion of the total variation. Let me let you write that. It is a proportion or a fraction of the total variability in the dependent variable. A fraction or a percentage of the total sample variation in the dependent variable that is explained by all the independent variables. The fraction of the total variability in the dependent variable, in this case, the dependent variable is quantity demanded, that is explained by all the independent variables put together. So that variability, that total variation in the dependent variable, in this case, the total variation in the quantity demanded of Jane. There are so many variations, there's so many variations, but the total variation of this quantity demanded, whatever is causing the behavior, all put together, the R square will tell you the percentage value of that put together. Okay, and there's a formula for it. Okay. Sometimes it's called the RSS, the regression sum of squares, over the TSS, which is the total sum of squares. Okay, that is sometimes what it's called. But there's another formula that connects the R squared to the F test. And I kind of like that formula as well. Okay. So if you look at our value here, look at the multiple R. Oh, by the way, the R squared is measured in the table by the multiple R squared. Correct to 2 decimal places, what is the value? Correct to 2 decimal places, what is the value in our case? The R squared. Dorothy.
0.99.
That's it. So guys, when you look down here, you see that that is the value of the R squared. Correct to 2 decimal places is 99%. It's not 100% though, it's 99%. The question was, is the regression model well fit? The regression model is always said to be well fit if the R square is bigger than 50%. The regression model is said to be well fit if the R square is bigger than 50%. The authors who made this point were Hare et al. 2005. So Hare et al. 2005, they give that, and I kind of endorse it, that the regression model is well fit when the R square is 50% or more. That is when we say that the regression model is well fit. That means that the regression model is reliable. So let me ask you, ladies and gentlemen, when you look at our regression model, is it reliable or is not reliable? If you haven't spoken today, this is your time. In our example we have here, our regression model that we have, is it reliable or it is not reliable? There are some people, if you give them all the chance in the world to just take $1 million, you just lay it in front of them, they won't take it. It's like they were not born to win in anything. But some people, they are born to win in everything. Jennifer Jackson.
Sir, please, the R square is reliable because it is more than 50%.
What is the value?
0.99. It's 99%.
Which is more than
50%.
No, that's it. This one is a fairly simple thing. But who can interpret that value of 99%? Who can interpret that for me? What does that mean? I've defined the R square for you guys. So what does that 99% mean in terms of this whole story that we are discussing here? In connection with this whole group to data set, what does this 99% here mean to you? Lena.
It means that there's a strong relationship of the independent variables on the dependent variable?
Not really. Not really. Ooh, try. What does that mean? What does that 99% really mean? Honestly mean? Sefako.
Okay. Please, it means that price depends, quantity demanded depends 99% on the price. So when the price increases, there's a high possibility that the quantity demanded of a commodity would reduce. And if the price,
so that you don't get too confused. Remember that this multiple R squared, this R squared value we have is for everybody. It's not only for price. So you cannot connect it to only price. Everything, all the independent variables generated that 99%. So what does that 99% truly mean? Judith.
Sorry. So it means that the fractional proportion of the total variability in the quantity explained by the various independent variables we've seen is 99%.
That's it. So it means that all the independent variables, that is key word, all the predictors. Know that the independent variables are also called regressors or predictors. All the regressors they were able to explain 99% of the total variation in the quantity demanded of gem betas. You see, when you make it quantity demanded of gem betas, you are being practical instead of saying in the dependent variable. So 99% of the variation in the quantity demanded of gem betas was explained by all the independent variables. That is how you explain the R squared. And you will explain R squared in so many places. Isaac, you understand?
I have a question.
Good.
When you were given the rule for the R square, you said when R square is greater than 50%, it is well fit. So therefore, if R square is less than or equal to 50%, it's not fit. I just wanted that.
When R square is greater or equal to 50%.
Okay.
Yeah, so 50% is part of it.
And then Doc, sorry to take you back. The stars, does it have any attribute of ranking? Whether they are 3 stars, does it have any attribute of ranking?
Oh yes, if you want to rank, you can use them to rank. Okay, so 3 star is better than 2 stars, 2 star is better than 1 star, 1 star is better than 2.
Okay, thank you.
Now, but there is a default star, and the default star is 1 star, just so you know. But if you get 3 stars, is best. That's all it is. All right. Now, let's go to the next question. So down with the coefficient of determination, which is the R squared. Let's go with the next question. The next question is interpretation. Interpretation. You got to learn to interpret the independent variables. Now tell me, how many independent variables do we have? Yeah. In this whole regression result, how many independent variables do we have? If you haven't counted, start counting. How many independent variables do we have in total? Stop chilling and follow me, okay? Beauty.
Six, sir. We have 6.
Okay.
Hello, hello, sir.
Beauty, you have tried. That's not correct. How many independent variables do we have? Solomon.
9.
9. That is not correct. How many independent variables do we have? You see a very simple question I'm asking. I told you that if you don't pay attention, you will leave empty. How many independent variables do we have? Florence?
8.
8. Okay. So we have 8 independent variables. The intercept is not part of it. It's not an independent variable. So take note. Now, how many of these independent variables are numerical and how many are categorical? How many of these independent variables are numerical and how many are categorical? Abbas. Oh, no. Wait. Yeah, Abbas. Oh, no. I didn't see.
Can I continue?
Yeah, go ahead.
There are 3 numerical variables and 5 categorical variables.
Good. So ladies and gentlemen, the last 5 are the categorical variables. Now we are about to interpret them. And the reason why this is important, and by the way, this takes a lot of marks in the exams too, is because the way you interpret the categorical variables are different from the way you interpret the numerical ones. I'm going to interpret one numerical variable. Then I will interpret one categorical variable. Then I will ask any one of you for 3 or 4 months to interpret the others for me. I hope you have been following. I'll wait for you to write the interpretation so that you can make sense of it. And I'll explain the interpretation for you. This is important because interpretation is key, very key in regression analysis. All right, so if you are ready, let's flow. I'm going to interpret price first.
The question.
Yes, go ahead.
So with the reference category, how will you know whether they are significant or not, or is irrelevant?
Well, you use some 2 strange words here. With a reference category, you said.
Yes.
How will you know that they are significant?
Or not?
You don't know unless you compare. The way you use reference means that you got to refer them to something else. And you're going to see that I'll be talking about them relative to something else. You cannot say that's a woman, because once you say a woman, you are implicitly also saying a man. So for example, if I say she is not a man, what am I saying? In terms of sex, I'm saying that she is what? A woman. If I say that, okay, it is not on the left, I'm saying that it's on the right. Listen. Okay. So categorical variables, once you identify the reference, implicitly, you're also talking about the other. All right, so I hope you get it. When we come to the interpretation, get it. So let's write the interpretation for price down.
So this is just, I have a little question.
Yeah.
In terms of, for instance, if it is not on the left, it is on the right. Someone who thinks deeply, sometimes the person may be thinking, okay, it can be in the middle, it can be, and even with gender now, there is this nonsense going on, and I mean, it may be complicated. How do we deal with it in future?
Technically, you can't say nonsense because it depends on where you are. Since we are in a global village, we are quite careful about the choices we say. But the key point is that I'm talking about things general. Don't go deep into middle. Because suppose I'm driving and then he says that take the first exit, take the second exit. And let's assume that you have a T junction and he wants to tell you that take right, take left. You know, I'm just, for example, your hand, you have left and right hand. So if I say that I use my left hand. It simply means I did not use my right hand. So I don't want us to go into the technicalities of middle, quarter, northwest, northeast, and all of that. I was just using that to give you an explanation regarding how, the reference category is deduced from the others, and you don't need to worry about what the reference category is going to be, because you would have known that from the others. And in this question, there was clear writing that in the data set, you knew that we had, once I say location urban, I'm comparing it with what? Once I say location urban, what am I comparing it with in this story? I'm comparing it with location rural. Okay, so whether there is some semi-urban, semi-rural, okay, in this very story, it was just rural, because this was in the story. That's what I'm saying. You are dealing with what you have been given. Okay, let's move on. You get it. You get it. Don't worry. I'm going to interpret price, and price is a numerical variable. So you start with, and this is a regression. Regression deals with the average or mean. So you start with on average. That's the word you started. If you're doing your interpretation and you never start with on average, you're in trouble. All interpretations you start with on average. Okay, so let's move on. On average, given the complement price of Jim, given the complement price of Jim, given the complement price of Jim, and I'm writing full grammar, English. Given the complement price of Jane, average income of the people, average income of the people, location of the shop, location of the shop, occupation and religion of the people, occupation and religion of the people, comma, a 1 unit increase in the price of gin, a 1 unit increase in the price of gin decreases the quantity demanded of gin bitters. A 1 unit increase in the price of gin decreases the quantity demanded of gin bitters by 3.15 units. By 3.15 units. On average, given the complement price of gin, income of the people, average income of the people, location of the shop, occupation and religion of the people, a 1 unit increase in the price of gin reduces the quantity demanded of gin bitters by 3.15 units. Okay, so let's look at some keywords. The word given, it includes all the factors that you are not explaining. Because you were explaining the price of gin, it was not part of those given. It's the first thing you want to take. Also, you did not mention income of the shop. It was income of the average income of the people. So you got to know the English grammar that you will use to write well, so that it will make practical sense to the ears. It's average income of the people. You didn't say that location of the people. No, It was location of the shop. Because you remember the storyline. And then when you go to the occupation and religion, of course, they are all of the people. You didn't say occupation teaching and occupation trading of the people. Neither did you say religion Christian and religion Muslim of the people. You rather combine them as a collective name, occupation and religion. Then you indicated that a 1 unit increase in the price of gin. Now you're coming to the price. So the value that you have, the negative 3.15, is not for the price, but it's for the other one, which is the quantity. As for price, it is increasing, in this case, increasing by 1 unit. Watch, I didn't say a 1% increase in price. I didn't say a $1 increase in price. I didn't say a £1 increase in price or 1 CD increase in price. No, what I said is a 1 unit. So I kept the unit of measurement to the word unit so that it doesn't conflict with anything. And I said 1 unit increase in the price of gin decreases the quantity. Why did I use the word decreases and not increases? Isaac.
Because of the negative sign in front of the 3. So it's negative
in front of the 3. So it decreases the quantity demanded by 3.15. I converted that 3.15 to 2 decimals and added units, not dollars, not percentage. When you normally have logarithms or logs, then you can be using percentage increases and things. So now that I've interpreted this, who can interpret for me the income of the people, the average income of the people, M? Who can interpret the coefficient of M? Okay, and I'll be listening with a critical mind. Okay, so when you start, you have to probably write what you're going to say down before you raise your hand, because once you start slowing down, it means that you are thinking too much about what you are saying. That means that I need to stop you for another person to pick up. So note clearly what you're going to write, and then let's start. Who will set the ball rolling? Richard Beidou, are you there?
Yes, please.
Please go ahead.
Okay, so on average, given the complement price of gin, the average income of the people, the location of the shop, the occupation and religion of the people, a 1 unit increase in the price of gin will decrease.
All right, so that's wrong from the onset.
9 units.
That was very wrong from the onset. Who can quickly tell me some of the wrong things that he made? Quick ones. So that we can, Richard, that was wrong. I mean, that was not correct at all. But let's try to help you to know the wrong ones, then you can now proceed. What were some of the wrong things that he made? Isaac.
When you said the average income of the people, yes, you should have waited. I think you should have taken to the latter part, because that's what he is going to explain. Okay. He's going to explain the effects of the income on the people.
Exactly. So since you're going to explain average income of the people, you don't have to include that in the explanation. And secondly, he also didn't talk about the price of gin. He started rather with the complement price of gin. Okay, so Isaac, you got 2 marks for correcting that. Now, who can do a proper interpretation this time? Remember, correcting is also power that you are drawing, giving out, not just interpreting it. Concept.
Okay, so hey, which Hansen? Sorry.
Yeah, you.
Okay, so on average, given the price of gin and the complement price of gin, and also the location of the shop and occupation of the people, as well as the religion of the people, a 1 unit increase in price of the people would decrease the quantity demanded of gin bitters by 0.98 units.
That is also wrong.
Okay, let me retry.
Don't correct it. You need to correct. Remember, you have only one chance to say these things. You're not going to say multiple times to perfect yourself. So that's why I said it's nice to write it down. Otherwise, the first guy will have to say it all again. Okay. So that was wrong. Who can tell me what was wrong in his own? And guys, you have to be listening to say what is wrong. Justice, what was wrong?
He was at the tail end, he was trying to explain the effects of the increase in price instead of income.
Thank you. That's it. So you got 2 marks for detecting that wrong. Okay. So be cognizant of what you are doing. Maybe document it down. Don't just feel you know you can do it. I can say it. I mean, I know it. You are wrong already by thinking that way. It is something very peculiar. And I'm listening to every word you pour out. Okay, Edwin.
Hello. On average, given the price of gin, the complement price of gin, the location of the shop, the occupation and religion of the people, a 1 unit increase in the income of the people decreases the quantity demanded of gin by 0.98 units.
Excellent. Perfect answer for 3. So that is how you interpret that of income. Okay, that's how you interpret that of income. So you got to learn, guys, you got to learn. This is 7 marks alone for each one. Okay, in an exam situation, you got to learn how to interpret. Now, sometimes in a practical thesis work, you tend to say that holding all other factors constant, blah, 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 blah. But I want you guys to learn factors for your level, learn the factors. Okay, I can simply say holding all other factors constant, and why need to increase in the price of blah, 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 blah. And it's also nice. This one is just a bonus, I'm telling you, if you're writing a thesis. It's also nice to indicate whether what you have interpreted is significant. So for example, when I interpreted a price.
Please, I have a question.
Yeah, hold on. When I interpreted a price after on average and everything, and then I ended with a 1 unit increase in the price of gin reduces the quantity demanded of gin by 3.15 units. And this price increase is statistically significant at 10% or at 5%. So in other words, you got to know when you're writing actual thesis, you got to know whether it's significant and at what percent is it significant. You got to know that in addition to your interpretation. I didn't add that, but I just want to flag that on the side that you got to know, that interpretation, whether it's significant or it's not significant. All right, Sevako.
All right, thank you. From the interpretation, we are talking about an increase and increase and increase, but we know that the relationship is negative. Would it be prudent to write an increase and after that write a decrease? And
that's
if
what I'm saying.
Come again, please.
That is what everybody has been saying. Increase, decrease. That is a negative relationship.
Okay. So if you are writing the interpretation, after you also need to speak about the decrease, right?
No, you don't need to speak about the decrease. What I'm saying is that the relationship can start by saying that a 1 unit increase in price leads to a 3.5 unit decrease in quantity demanded. Or a 1 unit decrease in price leads to a 3.15 increase in quantity demanded. Either one is fine, but don't do both.
The two. Okay. All right. Thank you.
All right, let's go to the categorical variables. Okay. Let's go to the categorical variables. And at this stage, I'm going to interpret the coefficient of occupation teaching. Remember,
I have a question.
Yeah, go ahead.
Please, you just said that sometimes we should just add the significance level. So I want to find out the star that is associated with the P. Should you take it into consideration when you are explaining the significance level? So for instance, the price, the P, you said the dot is, the significance is at 10%. So in this case, you say, and this price increase is significant at 10%. Is that how we put it?
Exactly, exactly. And I'm saying that it's not compulsory, but it's a bonus because that's at a higher level. And when you do that, it's a very good thing. It's good you've asked. It shows you are following. You are swimming, mate. Isaac, you are swimming in this music. I know somebody is there, also swimmingly sleeping. All right, occupation trading. Occupation doesn't rise and fall, okay? Occupation does not rise and it falls. No, that's not what it does. Occupation is a dummy variable. It's a categorical variable. It doesn't rise and fall. Religion doesn't rise and fall. So when you're interpreting dummy variables, the way you interpret them, you can't say a y unit increase, a y unit increase. So watch how we interpret dummy. We'll start with the same on average. Okay. So on average, given the price and complement price of gin, on average, given the price and complement price of gin, the average income of the people, location of the shop, and religion of the people. Quantity demanded is predicted or expected to be. Quantity demanded is predicted or expected to be 19.43 units less. Quantity demanded is expected or predicted to be 19.43 units less if the people are teachers. If the people are teachers than fishes. If the people are than if the people are teachers than fishes. And this is second at 0.1%. So I wanted to look at what you've written. You will notice that I still brought on average, and then given all of the other factors I mentioned. And when I got to the occupation teaching, I did not include that as part of those given. And once I did not include anything about occupation teaching, I did not also include anything about occupation. So that's one thing. You will not have to say that since you are interpreting occupation teaching, then you can include occupation trading. No, you're not including anything about occupation. Then I started rather with the dependent variable, quantity demanded. As a quantity demanded is predicted to be or is expected to be. Not that quantity demanded rises, no. It's predicted or is expected to be. In other words, you are a man or a woman, or you are a straight, or you are bisexual. You are, it's not rising and falling. It's not rising and falling like price and quantity and things we look. Religion, you don't rise and fall in religion every year. Okay. And by the way, when we talk about rise and fall, we are talking about within a limited time of a year. So quantity demanded is predicted to be blah, 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 blah. Then I said it's predicted to be 19.43 units less. Why less? Less is for the negative sign in front of 19.43. More is when it is a positive value. And then I had a reference category in my mind. So before I interpreted occupation teaching, I recalculated in my mind that which one is a reference category. And I knew that the reference category for occupation was fishing. That is why fishing is not in the result. But I know from the story, from the preamble, fishing was part of the levels of occupation. And since that had not come in the result of R, then that happens to be the reference category. The reference category is always the level of the dummy in which you don't see in the result. And R will automatically take one of them as a reference category. So that is the one you don't see. So once you don't see that, then everything you mention. So once I mention teaching, I'm mentioning teaching relative to fishing. Once I mention trading, I am mentioning trading relative to fishing. That's why fishing is not there. Fishing not being there is a reference category. So before you interpret any categorical variable, you got to know its reference category there before you start. Any question on this? You got to start putting your own down on how you're going to interpret some of them. Who can interpret the coefficient of religion Christians? Who can interpret the coefficient of religion Christians? You want to kind of scribble it, write it down some way, somehow, before you rush, so that you get stuck somewhere. And then you say, oh, sorry, let me come back again. All right, Nyako.
So let me try. On average, given the price and complement price of gin, the average income of the people, location of the shop is predicted or expected to be 15.55 units more if the people are Christians than Muslims and Buddhists. Okay. And this is significant at 0.1%.
Okay, so that's wrong. Nice try. Who can interpret the coefficient of religion Christians? You were cutting off, by the way, but the mistakes came earlier. Who can interpret the coefficient of religion Christians? Solomon.
Okay, hello, sir. Yeah. So on average, given the price and complement price of gin, the average income of people, the location of shop, and occupation of the people, the quantity demanded is predicted or expected to be 15.55 more if the religion of the people were Christians and not Muslims or Buddhists.
That is wrong. Oh. And by the way, you made a lot of mistakes, about 4 mistakes in your work. Who can tell me some of the mistakes you made, by the way? Who can tell me some of the mistakes that you made? Because that's an indication that you are listening. Yes, Abbas.
You mentioned more than one reference category.
Good. That's one of the mistakes. Who also saw another mistake made? Abraham.
He added Muslims in addition to the religion.
That was the same
instead
thing.
of
That was the same thing Abbas mentioned. The other thing he missed was the word unit.
unit. Yes.
He didn't bring the word unit. Okay. All right. So who can now do a correction of what he did? Isaac.
On average, given the price and complement price of gin, average income of the people, location of the shop, religion of, occupation of the people, quantity demanded is predicted or expected to be 15.55 units more if the people are Christians than Buddhists.
To be honest, I wasn't following. Was he right? Those of you whose hands are up, was he right?
Yes.
Yes, please, he's right.
Yes, please.
Yes, sir.
That's right.
Somebody wants him to fail so that the person will take over. Enemies of progress. Isaac, they will not succeed, eh? Isaac, they will succeed. Somebody says, no, the guy must have failed. I must get my 3 marks from here. Okay. So that was very good 3 that you just executed. Okay. That is it. It was a positive value. Now, who can interpret the coefficient of occupation and location urban? Who can interpret the coefficient of location urban? Location urban. Location urban. Hansen.
Okay, on average, given the price of gin, the average complement price of gin, the income of the people, the occupation of the people, the occupation of the people, the religion of the people, quantity demanded is expected to be 5.10 units less if the people are urban than if the people are from an urban location than rural location.
Okay, that's wrong. Hey. You are rushing. Okay. And that was I just love the way that he said hey. He was really, really surprised that he was wrong. Oh my oh really? Life does not reward you according to your definitions. Life rewards you according to the quality of your definition. Okay, so that was not correct. There were 2 mistakes that you made in the work. Who can correct it? Who can correct it? Don't correct it. You can say the correct one. So you see, you got to learn how to interpret. Abraham.
On average, given the price and the complement price of gin, the average income of the people, the occupation of the and religion of the people, quantity demanded is expected to be 5.11 units less if the people are from urban areas than rural areas.
Perfect answer. That's 3. Excellent. No mistake.
Doc.
Yes.
But that's not like what I said. I don't see the difference.
That's a big difference. He did not even, he got it wrong with the 5.11. He didn't say 5.11. Do you all remember? I was very...
Okay. Yeah, he said 5.11.
Okay. No, I'm talking about the previous guy. The previous guy, who got it wrong. He said 5.10.
Oh, okay. So at least 2 marks.
5.100. That is what he indicated. So that is the point.
Doug, I have a question.
Yeah, go ahead.
The location, is it related to the shop or the people?
Shop.
Okay.
Yeah, sure. All right. So that brings us to the end of the entire caboodle for today. Next week, we are going to do formulation of the regression model, then the equation, and then we shall now do prediction. So take note. Next week, we shall do the modeling, the equation, and then we shall complete with the prediction. We'll also do multicollinearity, how to solve the multicollinearity. And then I'll tell you a summary of your assignment. Okay? The assignment to be uploaded on Monday. And then I'll tell you a summary of your assignment that you have to submit. That's it for today. Any question? Any question at all?